Imagine ordering a house as easily as typing. Document, only instead of paper, concrete. And instead of several weeks of work, just one day. Yeah, this isn't fantasy. Already today, 3D printers are building houses faster, cheaper, and stronger than traditional methods. How does it work? A giant robot extrudes a special building mixture layer by layer, literally drawing the walls of the house. On average, it takes about 12 to 24 hours. Then they add the windows, the roof, the utilities, and that's it. The house is ready. The main advantages are speed and cost savings. Durability. The technology was first tested in China and the USA, and now such houses are being built in Europe, Russia, the UAE, and even in Africa. This is especially useful for quick housing, after disasters, or for cheap homes for poor families. But this is just the beginning. In the future, 3D printers will be able to build entire skyscrapers, space stations, and even cities. On Mars, self-healing concrete. Concrete is the basis of everything. Without it, there would be no cities, bridges, and skyscrapers. But it has a weak point: cracks. A small crack turns into a big one, and in a few years, a building could just collapse. But imagine concrete that heals itself. No cracks, no repairs, no billion-dollar expenses for restoring roads and buildings. This technology is based on bacteria that live in the concrete. As soon as a crack appears in the wall and water seeps in, the bacteria activate and release a substance that literally fills the void and heals the concrete. In the future, this concrete will become the standard. Imagine cities where there are never any ruined buildings. Sounds like science fiction, but it's already a reality. Unusual builders. Construction is a dangerous and tough job. But now, instead of people, robots are increasingly doing the work. They don't get tired, they don't make mistakes, and they can build 3 times faster. For example, in Japan they are testing humanoid robots that lay bricks, install beams, and even weld metal. In the US, robots are building modular homes. In China, they're raising entire buildings without a single person on site. But there are downsides. If robots are going to build everything, what will happen to the workers? Right now, the profession of a builder is becoming less in demand. So, what will happen in 10 years? Maybe the builders of the future will be engineers who manage an army of robots. Wooden skyscrapers. Sounds crazy, right? Wood is such a fragile and flammable material. But new processing technologies are being developed. It's stronger than steel and more durable than concrete. Today, they're building skyscrapers out of wood that are over 30 stories tall. What's their secret? Composite materials are pressed, soaked with special substances, and made super strong. Eco-friendliness. Wooden buildings cut the carbon footprint in half. Beauty. A warm, cozy interior instead of cold concrete. These kinds of skyscrapers are already being built in Norway, Canada, Japan, and the U.S. In the future, cities will be made of wood, and concrete and steel will be a thing of the past. Graphene in construction. Graphene is a wonder material that's 200 times stronger than steel and yet lighter than paper. Scientists say it's going to change everything, from electronics to spaceships. But why is it important for construction? Graphene walls are 5 times lighter and 10 times stronger than concrete. Anti-corrosion coatings, bridges and houses do not rust. Self-charging rooftop uses graphene to conduct electricity and could replace solar panels. For now, graphene is expensive, but scientists are already developing ways to make it cheaper. In the next 10 years, buildings will become significantly stronger, lighter, and smarter, thanks to this material. Water-repellent materials. Imagine a building that never gets wet. Rain just rolls off it like water off a duck's feathers. The walls stay clean, and the facade looks brand new, even after decades. This is possible thanks to water-repellent materials. These coatings are already being used on bridges, skyscrapers, and monuments. They not only repel water, but also protect the surface from dirt, mold, and corrosion. This means that buildings maintain their strength for longer, and owners save millions of dollars on repairs. But what's most interesting is that scientists are developing self-cleaning walls that could completely rid cities of dirty facades. Imagine New York or London, where the buildings always look like they were just built. The future is already here, and soon water-repellent materials will become the standard for all buildings. Wind-resistant facades. What if a building not only consumes energy but also generates it? Modern technologies allow us to turn ordinary walls into real power plants. Engineers have developed facades that capture wind and convert it into electricity. Special micro-turbines are installed directly on the walls or in the gaps between panels. Even a slight wind sets them in motion, and energy enters the building. Right now, these technologies are being tested in Dubai and Tokyo. In the future, this could completely change cities. Buildings will become self-sufficient, and electricity bills will disappear. Maybe someday even regular residential homes will power themselves without the help of power plants. Glass solar panels? Regular solar panels are those big black panels that ruin the look of buildings. But what if energy could come right through the windows? Modern engineers have already created transparent solar panels. They look like ordinary glass, but are capable of generating electricity. The whole secret is in nanoparticles that transmit light but convert it into energy. These windows are already being tested in skyscrapers in New York and Shanghai. In the future, they will be able to completely replace traditional solar panels, and every window in the house will generate electricity. This means that buildings will be able to power themselves without wires and extra installations. Imagine a world where every home is a little power plant. This technology could revolutionize the entire energy sector. Holographic projections in design. Construction starts with blueprints. Previously, architects used paper, then computer models. But now engineers are creating buildings right in the air using holograms. Modern holographic technologies allow us to see the future of a building in real space. An architect can literally go inside a project, change the layout, or check how every detail will look. It's not just convenient, it saves millions of dollars. Mistakes can be spotted even before construction begins. Projects are created faster, and buildings more precisely. In the future, this technology could replace traditional architectural models. Maybe even regular folks will be able to try out the design of their apartment in real time. Drones on the construction site. Drones have been used in the military for a long time, but now they're becoming an essential part of construction. Drones are capable of surveying a construction site and measuring height in a matter of minutes. Check the strength of the structure and even track errors. This speeds up the construction process and makes it safer. But the most amazing thing is that drones have already learned to build. Miniature flying robots that weave web-like structures are being tested in London. In the future, such drones will be able to erect buildings in hard-to-reach places, for example, on mountaintops or in space. A world where construction workers are replaced by driverless cars no longer seems like science fiction. In 10 years, drones could completely change the entire construction industry. Digital twins of buildings. Imagine being able to create an exact digital replica of a building before it is built. It's not just a 3D model, it's a full-fledged virtual twin that reacts to the environment, predicts failures, and even suggests which materials are best to use. These technologies are already being used in the construction of skyscrapers and bridges. They allow us to identify weak points in the structure even before work begins. For example, if the program shows that the bridge will develop cracks in 10 years, engineers can reinforce its structure in advance. But the most interesting thing is that digital twins can use artificial intelligence. Buildings will be able to talk to engineers, reporting problems and even offering solutions. In the future, all homes, roads, and bridges will have their own digital copies. It will completely change the approach to construction and repairs. Modular construction. Houses used to take years to build, but now they can be assembled in a few days, all thanks to modular construction. Instead of erecting a building on site, it is assembled in separate modules at a factory, brought to the construction site and connected like parts of a construction set. This method is already actively used in Europe, China, and the USA. In New York, there are residential complexes assembled from modules, and in China, a 30-story hotel was built in just 15 days. In the future, this method could completely replace traditional construction. Houses will be built in factories and then simply installed on the desired site. This will make housing cheaper and more accessible. Thermochromic materials. Imagine walls that change color depending on the temperature. In the summer, they turn light, reflecting sunlight and cooling the buildings, while in the winter, they darken, retaining heat. These materials are called thermochromic coatings, and they can save thousands of dollars on heating and air conditioning costs. In labs, they've already created windows that darken under the blazing sun and become transparent in cold weather. In the future, such materials could completely change the design of cities. Imagine homes that automatically adjust to the climate, getting warmer or cooler without using electricity. This is a real breakthrough in energy efficiency. Aerogels and insulation. Aerogels are a material that looks like smoke, but it's actually 100 times stronger than steel. It's almost weightless and is made up of 99% air. Its main feature is super insulation. Aerogels are capable of retaining heat, better than any known material. This means that with their help, you can create homes that practically don't need heating. Right now, aerogels are too expensive, but scientists are working on making the technology cheaper. In the future, this material will make homes warmer, lighter, and more durable. Biomimetics in construction. Nature is the best architect. Scientists are increasingly inspired by living organisms, creating buildings that mimic natural forms and mechanisms. For example, in Africa, a skyscraper has been built that cools itself in the same way as a termite mound. It hardly uses air conditioning, yet the temperature inside is always comfortable. Other buildings replicate the structure of shells, corals, and even spider webs. This makes them stronger, lighter, and more energy efficient. In the future, biomimetics could change the entire appearance of cities. Homes will be built according to the laws of nature, not traditional engineering schemes. It's not just beautiful, but it also saves millions on construction and maintenance. Liquid metal in structures. What if buildings could change their shape depending on the conditions? This is no longer science fiction. Scientists are developing a liquid metal that can adapt to stress and repair damage. This metal is inspired by nature. It behaves like living tissue. For example, if a crack appears in a wall, the liquid metal itself spreads and fills it, preventing destruction. The technology is currently being tested in laboratories, but in the future it could change the entire construction process. Perhaps soon there will be buildings that can heal themselves, like living organisms. Imagine bridges that never break, or houses that adapt to the weather by changing shape and structure. This is no longer science fiction. It's the next step in the evolution of architecture. Smart roads and bridges. Regular roads wear out, break down, and need constant repairs. But new technologies are changing the game. In Europe, they're already testing self-healing asphalt. They add metal particles that react to an electric charge. When a weak current is passed through the road, the cracks start to seal themselves up. Other roads have been developed that charge electric vehicles while they're on the move. They place special coils under the asphalt that transmit energy directly to the car batteries. Bridges are getting smarter too. The instructions embed sensors that warn of dangerous loads to avoid collapses. In the future, roads and bridges will not just be built, they will think, feel, and repair themselves. This will make travel safer and cheaper. Energy-efficient windows. Windows are the weak spot of any building. In the summer, they let in the heat, and in the winter, they let out the warmth. But new technologies are making windows smarter. Modern windows can automatically darken in bright sunlight, reducing the heating of the room. At night, they become transparent, helping to retain warmth. Some innovations allow windows to generate energy. They work like solar panels, but they still stay transparent. Imagine a city where every window helps save energy. This means that in the future, we might be able to forget about air conditioners and those huge electricity bills. Zero-waste construction. Construction is one of the dirtiest industries. Thousands of tons of concrete, metal, and would end up in landfills every year. But the new zero-waste philosophy is changing that situation. Instead of throwing away material scraps, they recycle and reuse them. For example, in Sweden they build houses from recycled concrete, and in Japan from plastic that was previously garbage. Other projects use bio-based materials that can be composted after the building is demolished. In the future, every house can be dismantled and transformed into a new one without harming the environment. This isn't just a trend, it's a necessity. Cities are growing, resources are running out, and construction needs to become eco-friendly and waste-free. Recycling buildings. Previously, old houses were simply torn down and sent to the landfill, but now, engineers have learned to recycle buildings, turning them into new building materials. For example, concrete is crushed and reused in new constructions. Old double-glazed windows are melted down into new windows. Even broken bricks are turned into decorative panels. But the most interesting thing is the buildings that can be dismantled and reassembled. In Holland, offices have already been built that can be completely disassembled into modules. When their lifespan is over, they aren't demolished. They are simply moved to another location and reassembled. In the future, every building will become a kind of construction set that can be used over and over again. This will change the very principle of construction. Buildings will no longer be something disposable. Living buildings. So, what if houses could grow like trees? Scientists are working on creating biological materials that can self-repair and even grow in size. One of the most promising technologies is living bricks. They are made from bacteria and can heal cracks like self-healing concrete. But most importantly, they can reproduce, which theoretically allows buildings to grow. There's also research being done on creating houses from mushrooms. Mycelium is a natural material that grows on its own and becomes incredibly strong once it dries. These houses will be able to self-repair and even heal damaged walls. The future of architecture might not be in concrete, and steel, and in living materials that can adapt to the environment. Nanomaterials in construction. Building materials could become thousands of times stronger and lighter if we change their structure at the molecular level. This is what nanotechnology is all about. One of the most promising developments is carbon nanotubes. They're 30 times stronger than steel, but they weigh hundreds of times less. If we replace traditional building materials with nanotubes, we could build skyscrapers a mile high without the risk of them collapsing. Another revolution is nanocoatings. They make materials waterproof, corrosion-resistant, and even self-cleaning. Imagine bridges that never rust, or houses that don't need cleaning. In the future, nanomaterials could completely replace concrete and steel, making buildings lighter, stronger, and more durable. Self-assembling structures. What if buildings could assemble themselves without any help from people? Scientists are already developing self-assembling structures that can fold up like origami. One of the most interesting projects is shape memory materials. They can change their structure in response to changes in temperature or electrical charge. For example, a house can be designed as a compact container, and then it unfolds into a full-fledged building in just a few minutes. Another idea is magnetic structures that assemble from modules, like magnetic blocks. Such technologies could be used for construction on the Moon and Mars, where every minute of work on the surface costs a lot of money. In the future, people might completely stop building houses by hand. Buildings will assemble automatically, without builders. Flexible skyscrapers. Traditional skyscrapers are rigid structures, but what if they could change shape depending on the conditions? Engineers are developing flexible buildings that can bend during earthquakes, hurricanes, or even just to improve aerodynamics. These designs are based on smart materials that can stretch, compress, and even breathe. For example, the walls of such buildings can open up to let in more fresh air during hot weather, or shrink during the cold season, saving heat. But the boldest idea is rotating skyscrapers. There are already projects for buildings where each floor can rotate independently from the others, creating a constantly changing silhouette. In the future, cities will become mobile, and buildings will be able to adapt to any conditions. Space construction. Humanity is already thinking about how to build not just on Earth, but also beyond it. The first target is the Moon. NASA and private companies are developing technologies for 3D printing lunar bases using local soil. This will allow for the creation of a settlement without the need to bring materials from Earth. Next step, Mars. Scientists are suggesting using bacteria and fungi that could grow buildings right on the surface of the red planet. And the most ambitious direction is orbital construction. In the future, huge space stations will be able to be built right in space using robots and nanotechnology. If humanity wants to become an interplanetary species, it will have to learn to build not just on Earth, but throughout the entire solar system.